Okay, so today we're going to look at the quotient rule, which of course means taking the derivative of a rational function where the denominator is not equal 0. And the derivative is actually a rational function itself. Okay, I'm going to start on the top. So the first thing we do is in this first spot right here, we take the derivative of the top, so g prime of x. In this second spot right here, we write down the bottom function, so h of x. Then we subtract, opposite to the product rule, of course. Then we're going to freeze the top function times the derivative of the bottom function. Okay, and then on the bottom, we actually keep the bottom function, but we square it. Okay, so we're going to actually do a proof of this function, of this derivative rule, and we're going to use yesterday's knowledge of the product rule to do that, okay? So this is a formal proof. Again, this is good practice for you. You could be asked to do this, and as I tell you all the time, next year you will be asked to do this even more often. Okay, so let's start with just our beginning. So we're going to say that if f of x equals g of x over h of x, okay, so there's our quotient function. Then we could actually write this as f of x times h of x equals g of x. And then using the product rule from yesterday, we can say that the derivative of g of x would equal f prime of x times h of x plus, freeze the first function, derivative of the second function. Okay, now just looking ahead to up above, we know that really based on our original function right here, we're trying to find the derivative of f of x. So we're actually trying to isolate this term right here. Okay, so we'll do a little reorganizing to try to isolate that term right there. Okay, so hopefully you can see obviously that the next step would be to take g prime of x and subtract f of x, h prime of x, and of course that would equal f prime of x, h of x. And I'll take it one step further and of course divide the h of x to the other side. So we'll just divide both pieces by it just to imagine this. Then we have f of x, h prime of x, all divided h of x. Okay, so now we've isolated f prime of x as we wanted. Okay, and now we can see that we're getting close to this derivative from above, but of course we don't have an f of x in this up here. So we're going to take f of x and we're actually just going to replace it. We know that f of x, of course, equals, just from our definition right above, equals g of x over h of x. So I'm going to go ahead and I'm going to replace that. Okay, so if we replace that over here, we get g prime of x over h of x minus g of x over h prime of x, and then we have another h of x on the bottom, so we now have h of x squared. Okay, and hopefully you can see that we're really close. We now just need to form a nice common denominator over there to make this work. Okay, and when we form a common denominator over here on the bottom, we get h of x squared, and of course that means the top simply needs another h of x minus, freeze the top, derivative of the bottom. And there you have the quotient rule that I first told you at the beginning of this lesson. Okay, so that's just a small little proof that we could do using our knowledge from yesterday, and now we're going to go ahead and practice with the quotient rule. All right, here we go. Let's take the derivative of this function. Okay, so I usually set it up by drawing my nice big giant line. I like to put the bottom down first, so we're going to square the bottom. Okay, in this spot right here, we always take the derivative of the top, which we know is 2x. Okay, times the bottom the way it is. It's a minus, so of course that means that the order is always going to matter. And then we leave the top function the way it is, take the derivative of the bottom, which is simply 2. So this is, of course, the key line of the derivative, and you want to get really good at this, and then we're going to work on our algebra, and we're just going to work on a little bit of simplifying. Important to note, of course, from last year, from rational functions and your knowledge, we never cancel. We have to simplify the top first and go from there, simplifying it as far as we can possibly go. Okay, so on the top, we're going to get 4x squared minus 2x minus 2x squared all over 2x minus 1 squared. Then we're going to get 2x squared minus 2x all over 2x minus 1 squared. And of course we can now factor the top. I don't think it's going to help us very much, but you always want to do it just to be sure, to make sure it doesn't cancel or simplify further. Plus, now it is in factored form, which we know is nice and useful. Okay, so there's the derivative of the first one. For the second one, you're going to notice that on the top we sort of have the product of two functions right there. Okay, so the easiest way to do this one, this is a pretty simple top to expand, so the easiest way to do this one would be just to expand out the top. So of course on the top we would get x squared minus x minus 2 all over x squared minus 6x. Once we've learned all the rules, we'll talk about the multiple ways to do this question, but that makes the most sense for now. So I would encourage you right now to even just stop the video and try to take the derivative of this on your own. Try the quotient rule. At least try the first line and then see if you can get the simplifying as well. Okay, let's talk through the first line just to make sure that you got that. So we're going to take the derivative. Don't forget to always say when you've taken the derivative. Giant line on the bottom function squared. On the top here, first spot right here, we have to take the derivative of the top, make sure if it's a binomial that it is in brackets. Okay, times the bottom, minus, freeze the top, times the derivative of the bottom. Okay, so there's your first key line there. And now you want to do some expanding and simplifying. And remember to always simplify the top first. And then let's see if you can get it. So pause the video, try it yourself, and I'll just complete the simplifying and you can see if you got it right. Okay, so here we have the simplified version. A couple things to note: you never need to expand the bottom. You do need to check to see if this factors, but if it doesn't factor, you don't need to do anything else with that. So you just want to simplify as far as you possibly can. Okay, let's try one more question, because of course we always need to apply this to an application. You've seen this question, it's not new, so now we can answer it using our quotient rule. So if this is our function, find the slope of the tangent at x equals 4. And I hope that if I asked you what you would do here right now, you would know exactly what to do. We're going to find the derivative using the quotient rule, and then we're going to sub in x equals 4. And of course, anytime we're substituting 4 in, you can simplify completely, but you don't really have to. You can sub 4 in right from that first key line. So again, I challenge you to pause the video and make sure that you can get the first line of the derivative of this function. Okay? Okay, how'd you do? Hopefully you got that right. Now, just as a little aside over here, I'm going to do it sort of down here. Okay, 1/2 x to the negative 1/2, just from our power rule on day 1. Don't forget is 1 over 2 x to the half, or 1 over 2 root x. Okay, so keep that in mind. You can kind of remember that when we're subbing in a value, that helps you out a lot. So let's go ahead and find f prime at 4, and I like to just go ahead and put my numbers in right off the bat. Okay, using our little aside down here, you can see that if I put 4 in here, I get 2, so that actually equals 1 over 4, that very first piece. Okay, if I put 4 into this piece right here, I'm going to I'm going to get 16 times 5, which is 80, minus 4, so I'm going to get 76. Okay, then I'm going to sub in my 4 right there, and of course that gives me the square root of 4, so that's just a 2. And then I'm going to sub in my 4 right here, and I'm going to get 40 minus 1, which is, of course, 39. Okay, and don't forget about the bottom. We already have that value right there. It's 76, but it's going to be 76 squared. Okay, and when I simplify that completely, I get negative 59 over 5,776. And no need to do anything else with that. That's the slope of the tangent line at x equals 4. Okay, so we'll do some good practicing tomorrow if you can be ready for that. See you then.